All right, today we're going to be looking at finding distance between segments and points. The first we're going to look at is finding the distance or the length of a segment. To measure the length of a segment, you can use a number line to find the distance between two endpoints. Our formula here says that we're going to have the absolute value of point B minus point A, where A and B are the endpoints of our line segment. So the first thing we want to do with our example right here says find the distance between -2 and 6 on a number line. Well, I'm going to call this one my point A, and I'm going to call this one my point B. So to find my distance between the two of them, the distance is equal to the absolute value of 6 minus a -2. Well, remember, if you have a minus and a negative side by side, that actually changes this to the absolute value of 6 plus 2. And 6 plus 2 is really 8. And the absolute value of 8 is only 8. So the distance between -2 and +6 is going to be 8. Looking at our next example here, it says find the distance between PQ, QR, and PR on this number line shown. So starting with PQ right here. So here's P, here's Q. So I want you to find the distance between the two of these. So my distance formula says D is equal to, the distance is equal to, I always like to take the one on the right minus the one on the left. So I'm going to have -2 minus the one on the left, which is my point P, and that one's at a -3.5. So I subtract everything inside the absolute value bars. So I have -2. Well, actually, first I'm going to take and change that. So -2 plus 3.5. Now I'm going to have to subtract. So this becomes 1.5. And the absolute value of 1.5 is just 1.5. So the distance between P and Q is 1.5 units. Now we're looking for the distance here between Q and R. Between Q and R. Here's point Q, here's point R. The distance between these 2 points. Again, take the point furthest to the right, which is R. It's located at a positive 2.5. And subtract the point furthest to the left, which that's point Q, which is located at -2. First thing I have right here is a minus and a negative make that plus, so this becomes 2.5 plus 2. 2.5 plus 2 is 4.5. And I take the absolute value of 4.5, which is still 4.5. So the distance between Q and R is 4.5. Now we need to find the distance between point P and point R. Point P is right here. Point R is right here, and we're looking for the distance between these 2 points. Again, start with the point furthest to the right, point R. Point R is located at 2.5 minus point P. Point P is located at a -3.5. Anytime you have a minus and a negative side by side like this, turns that into a plus. So I now have the absolute value of 2.5 plus 3.5. So I now have 6.0 or 6, and the absolute value of 6 is just 6. So the distance between P and R is 6. If you notice, if I add PQ plus QR, that will also equal PR. We're now going to go through, instead of just looking at a number line, we're going to be looking at how to find the distance between 2 points on the coordinate plane. We're going to be finding its length using our distance formula, and our distance formula says we're going to take the square root of x1 minus x2 and then square it, plus the difference of y1 minus y2 and square that. So looking at our first example here, it says find the distance between 5, negative 2, and negative 2, negative 3. First thing I like to always do is go through and label them. My first set of points, x1, y1. Second set, x2, y2. Now that I have them labeled, I'm going to go back to my distance formula and just substitute. We're here working for Glade. We're just going to plug it in. So it says I need x1 first. x1 is 5 minus x2. Well, x2 is a negative 2. I have to square those two after I subtract them. Plus y1. Well, y1 is a negative 2. Minus y2. Well, that's negative 3. And I'm going to square that. So I've got to do a little bit of arithmetic. Remember, this makes that a plus. So 5 plus 2 is 7, and I have to square it. Plus, here, these two right here make that plus. So negative 2 plus 3 gives me 1, and I have to square it. So I now have 7 squared, which is 49, plus 1 squared, which is 1, which gives me the square root of 50. If I simplify the radical, this would become the square root of 25 times 2, or 5 square root of 2, which is approximately 7.1. In our next example here, we want to go through and find the distance between points A and B on our coordinate plane here. First thing that I want to do with these is I want to go through and first find out where is point A located, where is point B located. Well, point A is located right here. It's at positive 2, negative 3. Point B is located at positive 1, 2, 3, 4, and then up 1, 2, 3, 4, 5. It's positive 4, 5. Next, label your points x1, y1, x2, y2. Now that I have everything labeled, I can go back and use my distance formula. So my distance is going to be equal to the square root of 2 minus 4 squared plus negative 3 minus 5 squared. A little bit of arithmetic inside here. So 2 minus 4 gives me a negative 2 squared. Negative 3 minus 5 is a negative 8 squared. Now I have to square each of these. Square root of negative 2 squared is going to be 4 plus 64. 4 and 64 gives me 68. Same thing as saying 4 times 17. 2 square root of 17, which is approximately 8.2. The main thing is with these is you got to pay attention to your formula, label the points as you go, take your time with what you're doing, and as always, good luck.